So we are in 2.14 and we are talking about scatter plots and how to draw lines of best fit. So scatter plot is again just a bunch of points that are all graphed in the same coordinate plane. So if we go ahead and label these, all right, we can see all these points right here. So I just made up all these points. These are all just random numbers that I just put in. Oftentimes you might have them relate to something. So you could have like, for example, after so many years, the height of a person is this much. Or after this many years, the weight of a person is on average this much. You could have it in terms of height, in terms of temperature, in terms of really anything you want. Students per class. There's so many different ways that you can take information and then track it. Could be related to money, all these different things. So I just kind of made up all these points, but in the homework and the classwork, you are going to see some problems that relate to actual data from charts and tables that have been collected over the years. So as you do this, we are just looking to try to make a line of best fit. So what that means is we are going to try to draw a line that matches up as best as possible with this data. So when we do these lines of best fit, we want to do a couple things. We don't want to just, randomly draw a line and be like, yeah, that looks good, okay? We kind of want to look at the data and see, first of all, is there even a correlation, all right? We know that a negative correlation would be going down over time, a positive correlation would go up over time, and then no correlation would basically be if there's just a bunch of dots and there's really no pattern to where they are, all right? So in this case, we do have a positive correlation. We see that in general, these dots are going up over time. And what you want to do is you can kind of see that there's like this path that it kind of follows, right? And I can kind of draw these two parallel lines on either side, and you can kind of see that we're tracking the information kind of in this general direction. So as we draw this line of best fit, we're going to want to try to cut the points pretty much right in half and draw as best a line we can through this. So as I do this, this would not be a very good line. It's too far below. This is too far above. We're kind of trying to look for something that splits it almost perfectly right down the middle. And a lot of your graphs will look a little bit different. I think if I do something like this, that might look decent, something like that. So we're gonna put arrows on the end, and then we're gonna track all this information. So if I think about y equals mx plus b, I can look down here, and we can say that we're starting at -2, right? This graph is scaled by 2, 4, 6, 8, 10, so each grid mark is by 2 units. So I know that I'm going to have a -2 for my y-intercept. That's down here. And then I want to do what the slope is, right? My slope, I have to go, if we look for another point, let's see, somewhere along, this one up here looks like a good point. So we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Times 2 is 22. So we're going up 22. And then we're going right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2 is 20. All right, so we're going to have y equals 22 over 20x minus 2. If we reduce this, this would be y equals 11 tenths x minus 2. So that's just a little bit over 1. That's like 1.1 there. So we can see that we start at -2 and we go up 1.1 over time. Now, what we can do is there's many different ways. I mean, not everybody's graph is going to look the exact same. For example, I might draw one that looks kind of like this, and I would honestly say that this is actually a pretty decent graph here as well. Obviously, it's a little bit different, but it does kind of split these points right down the middle. So I would say that's a decent graph as well. And if we look at this one has a y-intercept of -4. And if I look at the slope, let's try to find another point that works well. Looks like it does go right through there. We can see 1, 2, 3, 4, 5, 6, 7 times 2 is 14. So we got 14. And then 1, 2, 3, 4, 5 times 2 is 10. All right, so y equals 14 tenths x minus 4. We can reduce this, and we get 7/5 x minus 4. So this would also be a good graph. So you can see it's a little bit different. On these, I will give you some leeway, meaning that you might have a little bit of a different graph than somebody that you're working with. But as long as you are trying your best to kind of split that data right down the middle and you're not, being way far off. Like for example, if I drew this line, that blue would be very far off. This blue would be very far off. If I drew it at an angle like that, that's also pretty far off. Okay, so even though they kind of all meet here, I'm not doing a good job of showing that my slope should be kind of somewhat in this general direction here. All right, so make sure you're trying to match up as best as possible. In the 2.15, now this is all by hand, right? In the 2.15 notes, you're going to see how do we do this on our calculators, okay? So we'll do a little bit of review of this at the start of next class, but also make sure that you're bringing your calculators, because you will definitely need to bring your calculators so we know how to graph a linear regression, it's called, on your calculator. All right.